All right, in this next section, we're going to be looking at the graphs of quadratic functions. And so we'll start off by just looking at the most basic function, quadratic function, and that is the function f of x equals x squared. Okay, it's really the most basic quadratic function. Doesn't have a lot of terms in it. The coefficient is 1. And so there's not a lot going on here. We just get a feel for what happens when you square an input. Okay, so we're going to start out looking at an XY table. We'll just set up a table of values and plug in some numbers and kind of see what comes out. Actually, we'll do this over on the left. So how do I write this? X and Y. All right, there we go. So let's plug in a few values. I'll start at 0, and maybe we'll just do some easy ones like 1 and 2 and 3. And maybe we'll throw some negatives in there as well. So let's throw -1 and 2 and 3 also. Okay, that should give us a good start. All right, so now for each of these values, if I were to plug them in, 0 squared, you just plug them in for x, right? So 0 squared is 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. And then we'll go to the negatives. -1 squared is 1. Right? It's positive. Oh, these should be negative. Sorry. -2 squared, well, you square the negative, makes +4. And -3 squared, square the negative again, and you get a +9. Okay, so each of these rows represents a point on the graph, and if I were to plot those points out, let's go ahead and start that down here. 4, 3, 2, 1, go there, 1, 2, 3, 4, extend that a little further. All right. Okay. So we're going to get a nice graph going. First point is 0, 0. So that one is right on the origin. Then you've got 1, 1. Again, I'm going to have all the grid lines 1 unit apart. So 1, 1 is 1 over 1 up. 2, 4 is 2 over 1, 2, 3, 4 up. And 3, 9 is 3 over 1, 2, 3, 4, 5, 6, 7, 8, 9 up. Okay. On the other side, -1, 1 is 1 back, 1 up. -2, 4 is 2 back, 4 up, 1, 2, 3, 4. And -3, 9 is 3 back, 9 up. What you might notice is that there are points here that are symmetric to each other. The 2 points down here toward the bottom are symmetric, the 2 points in the middle, and the 2 points on the top. Now, this actual quadratic function, x squared, doesn't just work with integers like I've used, but it also works with decimals and fractions, and so everything in between these can also be filled in. And so by connecting these dots using a smooth curve, I'll get the graph of the full quadratic. Okay, the full function. Now, actually not the full function because I can't extend it out indefinitely. These things will go out forever, but at least I can get it around in this grid that I have. Now notice that this is not going to be linear. First of all, it goes down and then comes back up again. But also, the increase is changing. So from 0 to 1, the rise is 1. But from 1 to 2, the rise is 3. And from 2 to 3, the rise is 1, 2, 3, 4, 5. And so the increase is changing. This can't be linear because the rate of change is changing. So instead it's going to be a curve. And so we're going to start at 0, 0. draw this curve up and to the right, and then we're going to do the same thing on the left, starting at 0, 0, and it's going to curve up and to the left. Now what you should end up with is something that is relatively smooth. You don't want a point at the bottom, you want it to kind of round off there. And you want these arrows to continue, even though they look like they go straight up, they actually go out to the right and left indefinitely. Okay. I want you to see also that there's some symmetry to this graph. I pointed it out before, but the whole graph is symmetrical. Every point on the graph has a point that's symmetrical across the y-axis. So there's some very important features to this graph that I need to point out. First of all, the y-axis, we'll start with the symmetry of this. The y-axis is the axis of symmetry. Okay, what that means then is that there's a mirror image on either side of the y-axis. If you folded this graph in half, right along the y-axis, the two halves would match up perfectly. Okay. Now, the y-axis has an equation. All vertical lines have an equation, x equals a number, and on the axis, the x value is 0. So we would call that x equals 0 is the axis of symmetry. Okay. We also have this lowest point here. Okay, it's called the vertex. All right, so the lowest point is called the vertex. Lowest point is the vertex. And in our case, it has coordinates 0, 0. It's the origin. Okay, it won't always be that, but in this particular example, it is. Another important feature of this graph is that both of these arrows, what I call the tails, are going in the upward direction. So we say that this graph opens upward. Okay, the direction that the tails go in would be the direction that it opens or faces. So some books call it different things. So we're going to say opens up or faces up. You could write it that way. Faces up, and that's because both arrows point upward. Both arrows point upward. Okay, so that's why we call that an opening up or facing up parabola. A couple other features of this parabola that we need to point out are the domain and the range. Okay, so the domain here is going to be all the numbers that you can plug into the function. Well, there's no problem with squaring numbers. You can plug anything in and get a square, right? Get its square. So the domain is going to be all real numbers. In other words, you can plug anything in indefinitely to the left and indefinitely to the right, and you'll get a value out. The range, there are some restrictions to the range, because when you square a number, you can't get a negative. You can only get 0 or positive values. So the range is going to start at 0 and go to infinity. That gives you 0 and all the positives, right? And from the graph you can see this. Starting at 0, this graph, both sides go up, neither side goes down. Okay, so it must be 0 to infinity on the range. One other thing that I want to point out then is that this graph is called a parabola. It has a name, P-A-R-A-B-O-L-A. All right. So the name of a graph of a quadratic function is a parabola. Okay, and it's going to have this smooth U-shaped graph to it.